Hello everyone, welcome to my channel proChem Academy. Today I will discuss about the carbonyl compounds. In last day of carbonyl compounds video, I have discussed about the main preparation of the carbonyl compound, that means aldehyde or ketones. Now today I will start from there where I have left in the last video. So if you have not seen that video, then please go in that video and see the video. It will be helpful for you. Okay. Now the link of the video will be given to your description box. Okay, so please that video, and if you have not subscribed my channel, then do subscribe. Okay, and please hit the bell icon so that whenever I upload the video, you will get the notification. Okay, now so today we will start the carbonyl compounds, other reactions, preparations of other method. Okay, of carbonyl compounds. Now the carbonyl compounds can be prepared from the hydroboration of alkene. Hydroboration of alkene. Okay, so this method is very important. Hydroboration. Now hydroboration can be done for alkene using the reagent B2H6, that means diborane. This compound is called diborane. Okay, diborane. With that the THF, trihydrofuran, as a solvent. Now B2H6 exists, it is nothing but the BH3 which exists as B2H6. Okay, and now the structure of the B2H6 is like this. This is actually the B2H6, which actually it is BH3 but exists as B2H6. It has this kind of structure which is called banana bond, 3 center 2 electron bond, 3 center 2 electron bond. Now this BH3 will actually take part in the reaction with the alkene to form trialkyl borane. When an alkene reacts with B2H6 in presence of trihydrofuran, it will form trialkyl borane. Now that trialkyl borane, when reacts with H2O2 per sodium hydroxide, it will form an alcohol. Now that alcohol, if reacts with the PCC, which is a mild oxidizing agent, I have discussed about the previous PCC in the previous video. Okay, see that video. With the CH2Cl2, then it will be converted to aldehyde. Now let me take one alkene, which is this one, CH3 CH double bond CH. This is propene. We all know that this is propene, one propane. Now when this reacts with B2H6 in presence of THF, it will form a trialkyl borane. Now trialkyl borane means the BH3 will react with this propene, actually the BH3. Now the every hydrogen of BH3 will be replaced by alkyl group formed from here. That means CH3 CH2 will be added with the boron, replacing each hydrogen. That means we will get trialkyl borane. CH3 CH2 will get 3 times with that boron, trialkyl borane. First of all, one hydrogen will be replaced by CH3 CH2 CH2. Then another hydrogen will be replaced by CH3 CH2 CH2. Then another hydrogen of BH3 will be replaced by CH3 CH2 CH2 to form trialkyl borane. Now this trialkyl borane, when reacts with H2O2 in presence of sodium hydroxide, then alcohol it will generate 3 moles of alcohol. That means this will form alcohol. Now when this alcohol treated with PCC in presence of CH2Cl2, then this CH2OH group will be converted to CHO. This CH2OH group will be converted to CHO. So we'll get this compound, propanaldehyde. Okay, this is propane from propanaldehyde, or propanal, we can say. You can say propanal. Okay, so this is a very important method to form an aldehyde from an alkene. Okay, so please write this video, write this note so that I can go into the next. Okay, so I'm erasing this one. Now we can apply another method which is called dehydration, which is called not the dehydration. We can apply the hydration on an alkene or an alkyne. So if I take alkyne, one alkyne, alkyne means HC triple bond CH, this is one alkyne. Okay, now this alkyne when treated with HgSO4 with H2SO4 at 60 degrees centigrade temperature with water, that means HOH, then as it is a symmetrical alkyne, as it is a symmetrical alkyne, that means if you cut this molecule by a plane here, then you will get the equimolecular or equal portion of same portion of CH. So any one of the carbon will take up this hydrogen and other carbon will take up this OH to form HCAH. One bond will be taken from here to form CHOH. Now this is very unstable compound. Now it will rearrange, that is by tautomerism it will form an aldehyde. That means this OH bond will be shifted to the C, that means one OH bond will be clicked, will be broken to form another C double bond. Now here, so that the valency of this carbon will increase, because 1, 2, 3, 4, it is making 5, so this bond will shift here. And it will take up one hydrogen to form CHH. Okay, HCH, another hydrogen will be there with C double bond OH. So it is nothing but your CH3CHO, acetaldehyde. It is nothing but acetaldehyde, and it is acetylene. Okay, so we can easily prepare the acetaldehyde from acetylene using mercurous sulfide, okay, with sulfuric acid 60 degrees centigrade with hydration. Now if you take an unsymmetrical alkyne, that means instead of this H, if you take CH3CH triple bond CH, then another kind of aldehyde or ketone you get. Okay, so see that reaction. Please note down this one. So I'm erasing this one. Okay, so we'll move into the next reaction. That means an unsymmetrical alkyne CH3 C triple bond CH when reacts with HOH, that means water, in presence of mercurous sulfur HgSO4 with 60 degrees centigrade and H2SO4. Then now here is a choice. That means in which carbon the H will be added, that means attached, and which carbon the OH will be attached. Now the OH will be attached with that carbon which is least substituted. Okay, now here one hydrogen is there, here no hydrogen, so it will be taken, it will take the OH. So here we will get CH3, C here OH, C, one bond will be clipped from here, that means double bond will be there with HH. Okay, now this is unstable compound, so it will tautomerize. Tautomerize means this OH bond, same as the previous reaction, this OH bond will be shifted towards this CO to form another C double bond, and this bond will be shifted here. So it will form CH3C double bond C H H. It will take one hydrogen to form this one. That means this will form CH3 CO CH3. It is nothing but acetone. That means 2 propanone. So you can easily convert one propine, this is propine to 2 propanone. Propine to 2 propanone by this reaction, that means hydration of alkyne. Okay, so please write this one. Okay, now we try to prepare the aldehyde or ketone from the Grignard reagent. We can easily prepare the aldehyde or ketone by using a Grignard reagent. Okay, now what is Grignard reagent I will tell you first, after that we will go into the reaction. Okay, now Grignard reagent means when Rx, that means alkyl halide is reacts with magnesium, that means electropositive metal with ether as a solvent in ether medium, then this will form RMgX. where this magnesium, this means this MgX is delta plus because it is electropositive, and this R is delta minus. This compound is called Grignard reagent. This compound is called Grignard reagent. Now here in R may be any group, that means CH3, C2H5, any group, and X can be chloride, bromide, iodide. Okay, now so we can take any Grignard reagent, CH3MgBr, CH3MgI, CH3MgCl, like that, and we can treat with cyanohydrin HCl. Okay, we can treat with HCl, hydrogen cyanide, to prepare one aldehyde or ketone, or we can react this RMGX with the ester, so that we can prepare the aldehyde or ketone. Okay, now we'll see those reactions first, how we can prepare. After that, this RMGX can react also with the aldehyde or ketone. That only also we'll see. So this is Grignard reagent. Now see, HC triple bond N, this is one hydrogen cyanide. Now by reacting with this hydrogen cyanide, one Grignard reagent, that means instead of this RMGX we can take CH3MgBr in presence of ether medium, ether. The reaction can be done, and from where we can get the aldehyde or ketone. Now what will happen, this is delta minus and this MgBr is delta plus. So this will attack this carbon and it will remove one bond from here to form HCCH3 double bond in H. Okay. Now if we hydrolyze this one, that means hydrolysis, it will generate, that means this double bond in H will be converted to double bond O. With that we will get ammonia, and MgBr. With that hydrogen, with that OH will get. So this is the compound which you are going to get here, HCCH3 double bond O NH3 MgOH-Br. So please write this one. So it is done. Now I am erasing this one. Now another way we can prepare the aldehyde or ketone by using a formal chloride or acetyl chloride. Okay, with the Grignard reagent. Now this is formal chloride, HCOOCl, formal chloride. Now this when reacts with RMGX, that means CH3MgBr or I in ether medium, then as this C double bond is polar in nature, that means this carbon is delta plus and this oxygen is delta minus. So easily this delta minus, that means CH3, can attack this carbon to facilitate the removal of this O minus to form HCO. Now it will form OMgBr. And here CH3 will be added and here Cl will be there. Now if we hydrolyze this one, then what we will get? We will get magnesium chloride here. We will get magnesium chloride with that ketone. That means this compound we are getting HC double bond of CH3. That means CH3CH. It is nothing but CH3CHO. That means acetaldehyde we are getting. Instead of this hydrogen, we can take CH3, so that another compound will take it. Okay, so these are the method from where we can prepare the aldehyde or ketone. Now another important reaction is there, which one we have to prepare that reaction, that is Rosenmund reaction. Rosenmund reaction, that can come as a name reaction also, and that is also important. Now Rosenmund reaction, in the Rosenmund reaction we can prepare aldehyde. By reacting with the CH3COCl, that means RCOCl. We can prepare benzaldehyde also if you take instead of R as a pH, as a benzene. Okay. Now in that the reagent should be a catalyst, palladium, with a barium sulfate. Palladium with barium sulfate. Now barium sulfate is the work of the barium sulfate is to poison the work of the catalyst, and is to poison to restrict the reaction at the earlier stage, because palladium can take the reaction in more higher order, but barium sulfate will poison the reaction at the earlier state, okay, in presence of hydrogen. So we can use the boiling xylene also there, so that reaction is also important, that is the Rosenmund reduction. Rosenmund reduction reaction. RCOCl with PdPSO4, hydrogen will be there with boiling xylene. Then this COCl will convert to CHO. With that we will get HCl. So this is very important reaction. Instead of this R, you can take CH3, COCl with the hydrogen, palladium BSO4, boiling xylene, then it will be, you will get CH3CHO plus HCl, that is acetaldehyde. So this is very important reaction, and it can come also as a name reaction. Okay, now next in today's video is up to this. In next video I will discuss about more reactions of the carbonyl compounds. So please subscribe my channel, and if you like this video then do like, comment and share. So thank you.